Hello students, how are you? I hope you are doing well. So today we are going to learn a new concept of chemistry, that is mole concept. So why mole concept is important? A lot of questions in chemistry based on chemical equations where you need to find how much amount of product will be formed, how much reactants will be consumed, or which is the excess reactant in the reaction, and which is the not the excess reagent, and how much amount of leftover reactant will remain after the reaction. All those kind of questions, and questions based on volumetric analysis, mixing volume, a lot of questions, those can be solved using the concept of moles. So that's why this mole concept becomes very important to understand. So let's start this mole concept. What is mole? So if we talk about the word meaning of mole, so mole word means a collection or heap. Okay, and if we talk conceptually, what is a mole? So a mole is seventh fundamental unit. And what are fundamental units? There are seven fundamental quantities: length, mass, time, thermodynamic temperature, electric current, luminous intensity, and the seventh one, amount of substance. These are seven fundamental quantities, and their corresponding units are called fundamental units. So the last added fundamental quantity, that is amount of substance, that has fundamental unit mole. So mole is the seventh fundamental unit. Now let's try to understand this. What is mole, and what is 1 mole, and how much is 1 mole? So 1 mole can be defined in three ways. So first definition says that molecular weight of a substance represented in gram is 1 mole of that substance. And second concept says that 6.023 into 10 raised to the power 23 particles of a substance will form its 1 mole. So 6.023 10 power 23, it can be anything like 6.023 10 power 23 chairs, that will be 1 mole chair. 6.023 into 10 raised to the power 23 dollars, so that will be 1 mole dollar. 6.023 into 10 raised to the power 23 protons, so that will be 1 mole of protons. So anything it can be. And the third concept, that is applicable only for gases. So that concept says that 22.4 liter volume of a gas at STP is equal to 1 mole of that gas. So STP here, STP means standard temperature and pressure, and which is a condition of temperature and pressure where temperature is 0 degree Celsius or 273.15 Kelvin, and pressure is 1 atmospheric pressure or 1.013 into 10 raised to the power 5 pascals. So all these three concepts are related and equivalent to each other, and we can understand it with an example. We are going to take of oxygen. So let's take example of oxygen. So oxygen is O2, molecular form of oxygen, and molecular weight of oxygen is 32 gram per mole. And if you look the unit carefully, it says 32 gram per mole, which itself describes that 32 gram oxygen is 1 mole of oxygen. So you can write that 1 mole oxygen gas, or simply you write 1 mole oxygen. It can be liquid or solid also. So 1 mole oxygen is equivalent to 32 gram oxygen. The first concept, molecular weight of a substance represented in gram, that is equivalent to its 1 mole. Similarly, if you connect it with the second concept that says 6.023 10 to the power 23 particles. So what is the particle form of oxygen gas? That is the molecular form, right? Because a gas exists in molecular form, not in atomic form. In atomic form it exists during the chemical reaction, but not in free states. In free state, the substances exist in the form of molecule. So 32 gram oxygen or 1 mole oxygen, that will be 6.023 into 10 raised to the power 23 oxygen molecules. And if you want to connect it with the third concept, then the same 1 mole oxygen or 32 gram oxygen or 6.023 into 10 raised to the power 23 oxygen molecules, they will occupy a volume of 22.4 liter at STP, means standard temperature and pressure. So all these four concepts, they can be they all are interconnected and they can be related to form a lot of questions. So like we can understand one question we can form with the help of this 32 gram oxygen and 6.023 10 power 23 oxygen molecules. So from here, suppose the question is what is the mass of one oxygen molecule. So you can simply calculate it using unitary law. So mass of one O2 molecule, how much that will be? So 6.023 10 power 23, this number is also called sometimes Avogadro number. Okay, so 6.023 10 power 23 molecules have 32 gram of mass. So one molecule will have 32 gram divided by 6.023 into 10 raised to power 23, right? You can simplify it. Similarly, you can calculate the second and this last concept together to form another question. So suppose question is what will be the volume of 8 gram oxygen at STP. So this is also very simple. Like you can see 32 gram of oxygen occupies 22.4 liters. So 8 gram of oxygen at STP will occupy 22.4 into 8 divided by 32. So that means 1 by 4 of 32.4 liters. So that will be 4 5 are 20 and 4 6 are 24. 5.6 liters. So if this will be directly question like find the volume of 8 gram oxygen at STP, maybe you will not get it how to solve it. But if you relate these two concepts like 32 gram oxygen occupies 22.4 liter volume at STP, then you can simply calculate 8 gram will occupy 22.4 divided by 4, that is 5.6 liter of volume at STP. Okay, so we will meet again with more advanced questions based on chemical equations and mole concept. Till then, take care, bye bye, and thank you very much for listening to me.